So we want to talk about the different types of numbers or different sets of numbers. So let's think back to when we started to count. We used tally numbers, so basically marks in clay tablets. So 1, 2, 5. We didn't even have symbols for numbers in early counting, but then we developed numbers such as, let's say, the Roman numerals 1, 2, and 3. These were originally called the counting numbers because they were used for counting objects. We call them in maths, we call them the natural numbers. So the natural number starts at 1 and goes all the way up to infinity. And we'll give that set of numbers the symbol n for natural numbers. So we can write an equation such as x is equal to 3. 3 is a natural number and belongs to that set. Well, we can write another equation, let's say x plus 3 is equal to 0. And that means that x is equal to minus 3. Now, minus 3 does not belong in the set of natural numbers. So we have to extend our set of numbers again. So in this case, we're going to extend it to what are called the integers. And the integers include all the natural numbers, but now include 0 and the negative numbers. And we give a symbol for that set, is given the symbol Z, because at the time this has been developed by German mathematicians, and they use the German for that set, which begins with Z. So we can write another expression now that extends that further. So 3x minus 1 is equal to 0. That means that x is equal to a third. Now, a third does not belong to the integer set because the integer set has to be whole numbers. It might be negative, but they're still whole numbers. So a third does not belong to that set. So we have to extend our set again, and we're going to extend that set to what are called the rational numbers. Now, the rational numbers are down to the that they can be expressed as a fraction or as a ratio. That's where the word rational comes in, the ratio at the beginning there. So any number that can be expressed as a fraction. So instead of giving it the symbol R for this set, we're going to give it the symbol Q because R is going to be used for a different set, and the letter Q is for quotient. So we're now going to extend that set even further. So if we say x squared minus 3 is equal to 0, x squared is equal to 3, and that means x is equal to plus or minus the square root of 3. Now, the square root of 3 cannot be expressed as a fraction, so it's not a rational number. So therefore, we have to extend our set again, and we extend that set to what are called the real numbers. So the real numbers include square root of 3, any number that can be expressed on the number line. So if I draw the number line down here, and we have 0 here, and 1, 2, 3, 4. If you think of pi, let's say pi is in between, that's pi. Pi is in between 3 and 4. E is in between 2 and 3. All these numbers here, square root of 3, all of the numbers belong on the, can be expressed on the number line. Now, there is a number that cannot be expressed on the number line, and we want to discuss that now. So if I give you an equation to look at that, so x squared plus 1 equal to 0, that means that x squared is equal to a minus 1. That means that x is equal to plus or minus the square root of minus 1. Now, the square root of minus 1 does not, that number cannot be expressed on the number line. And for that reason, we use a completely new symbol for that. That is the symbol I. We call that an imaginary number. So an imaginary number, it really does exist. It's not an imaginary thing, but it really does exist. And I is an imaginary number. Square root of minus 5 is an imaginary number. But they do not belong to the set of real numbers. Now, there is another set called the complex numbers. Now, the complex numbers include imaginary numbers and all the real numbers. So it's a number that has both a real part and an imaginary part. So 2 plus 3i. So 2 is the real part there, and 3i is the imaginary part. And the reason that the complex numbers are so important to learn is because this is the biggest set that you can get. There is no number outside of the complex numbers. Complex numbers are the biggest set of numbers that you can get, and that's why it's so important to understand complex numbers.